Okay, so yeah, so today we're doing extreme values, and before we start off with those, we got to go over some important definitions, and I will show you guys an example of this right away. So first we have an extreme value. Okay, so this is any max or minimum points at which a function assumes maximum or minimum values. Okay, we have absolute maximums, we have absolute minimums, and we also have relative maximum or a relative minimum. Okay, Aaron, you kind of made a comment on this yesterday. You're just like, that isn't the minimum, and you're absolutely right. It would have been like a relative minimum, right? Not an absolute minimum. It would have been a relative one. Okay, so you're right. Okay, but yeah, so absolute maximum. So this is the value of a function which is not exceeded by any other value of that function. There can only be one absolute maximum, and there can only be one absolute minimum function for any function, or value for any function, okay? Relative maximum or minimum is when it kind of is like when it's bending up and down, but it's not at the absolute maximum, okay? And it can also be a relative maximum as well. It can be both the relative maximum and the absolute maximum, okay? I'll show you guys an example. I know it's a lot of terminology, but it's not too bad once we actually look at it, okay? And then turning points, so these occur when a continuous function changes. So when it's like, when the slope is increasing and then the slope is decreasing, right? After one of those turning points. And then a stationary point, this occurs when a graph is neither increasing nor decreasing and the slope of the tangent is equal to 0, right? That's a horizontal tangent. That's just like the vertex of a parabola, essentially, right? The slope would be 0 because there's no rise. It would be all run, right? Okay, so that's the first few definitions. In order to identify extreme values, we use critical values. So this is values of x where the slope of the tangent is 0. So we call these stationary points or a horizontal tangent. Critical values. Okay, so the slope of the tangent is 0, stationary points, horizontal tangent. This is where y prime equals 0. Okay? Y prime equals 0. That's what I mean by that. The derivative, right? The general slope of a curve is equal to 0. Critical value, another one is when the slope of the tangent is undefined or infinite. That's when we have a vertical tangent, so that's when our y prime is equal to infinity. It's really hard to draw with the mouse, if you couldn't tell. Okay? Yeah. And then another critical value is where the graph begins or ends, right? That's quite important. Okay? So, let's go over an example. Let's see. We'll do this one first. Yeah, perfect. Okay, so I'm going to draw this weird, wacky looking, kind of roller coaster looking thing, to be honest. If you guys could do the same, that'd be great. Okay, so we go boom, boom. Okay, obnoxiously pointy for a reason. Okay, and we go boom.
I like your sound effects, please do not.
Boom. That's be on a roller coaster.
Approximate, or does it have to be like?
Just ish. Ish is fine.
Are you gonna put like points, like specific numbers on?
Yes, I will.
Oh boy.
Can I see your paper?
Oh yeah, it's like this big.
Oh,
That is literally exactly what mine looks like.
Perfect.
No.
Well done.
As your mind's moving.
We got a little ice cream cone right here.
Oh, suck it.
Look at it. Little ice cream cone. Okay, sorry. And then let's put some points on here. So we're gonna. Oh, I actually don't want this one to have an arrow. Sorry. So we have point A, point B. This is flat right here. This is point C. The ice cream cone is point D. Point E. And point F. Okay, So based off of the terminologies that we just kind of briefly went over, and this is like your quiz for tomorrow, okay? You're gonna get something that looks like this, and then you have to identify relative maximum, relative minimum, absolute max and min, turning points and stationary points. Okay, so
just put like A
beside what?
stationary points.
So stationary points, this is where y prime is going to equal 0. Those are our stationary points, okay?
Oh, could I do relative minimum?
Relative minimum, yep, A would be absolutely be a relative minimum, for sure. Okay, you guys have this all drawn out, right? Okay, I'm just gonna move down so I can actually write on here. Sorry, Emma. I hope you have yours drawn too. Okay, so let's identify which points will satisfy the following. So where do we have relative maximums on there?
B.
Yep, and
E.
B and E, good. Where do we have a relative minimum?
A.
Yep,
D.
and D, yep,
F.
yep,
Wait, wouldn't D be an absolute minimum?
yep, absolutely.
So is it not a relative?
It can be both. It can be both, yeah. Because in some cases where you don't have like a definitive absolute minimum, you're still gonna have relative minimums. Okay?
Okay.
And the minimums are just gonna be like the bottom part of like a parabola, right? Yeah. Good. Is there any absolute maximum? Is there a absolute maximum here?
The infinity.
Right, it goes on to infinity, right?
There's none.
But we don't know that point, right? So we say we do not have any absolute maximums.
Because it's not absolute, right?
Yeah, exactly. If there was like if it was, then this would be our absolute maximum, right? Assuming that this like continues to go down like that.
Or
That would be an absolute
could
maximum.
have both if it continues to go this way.
If it continues to go like this way,
Yeah.
so just like that.
Yeah.
Then it would be, yeah, as long as it's like definitively the tallest point on the graph, then it is the absolute point, right? But if it's not definitive, then they're relative maximums. That's okay? Okay, absolute minimum is D. And what about my turning points? Where does the graph turn?
B.
Yep,
D.
yep,
E.
yep.
F.
Yep, perfect. B, D, E, and F. And where is it stationary? Where, and I'm sorry to interrupt, Annabelle, so stationary would just be where y prime is equal to 0 again. Annabelle, sorry to cut you off.
81.
D? D is actually, it has a undefined tangent on it. So D is not going to be a stationary point, no.
But like C, just because the slope is.
C would absolutely have one for sure. And then what about right up here?
Oh,
If
Do we-
you draw a line.
We don't have any rise on it, right?
B.
So B, E I heard. And what's the last one?
A.
Nope. F, yeah. Okay.
So the top of any like curve would be a stationary point?
Yes.
Okay.
Yes. Yep.
Okay.
Yes. And that's just where y prime is equal to 0, where
So,
there's no slope on it.
Tomorrow, we're not gonna be like writing down the actual like meanings of these, or are we?
You will need to know the definitions for tomorrow. Yes. Yes. So,
You can like summarize them.
yep.
So I can just say max value is, or relative maximum is maximum taking into account the points around it.
Yeah, that would be good. Just make sure you explain yourself, right? And that you're clear and, yeah. Know your definitions. Okay? And also know how to identify these points. on that, okay? Yeah, so critical points B, C, E, and F have horizontal tangents. F prime of x equal to 0. D has a vertical tangent. It's undefined, right? Because it's, remember when we were doing like the limits? And we couldn't find the limit of something when it has like a really sharp turn like that,
Mm.
Yeah.
right? Kind of same thing, it's just hard. Well, yeah. So if it's a vertical tangent like a V, we say that's undefined. Okay? And A is a graph endpoint. So we just jump back up. That's just where it starts. That's why I didn't draw the line going down forever. Okay, so example 1. So using the first derivative test to find extreme values. Okay? So here's our function. So f of x is equal to x squared minus 3x plus 2, where x is greater than or equal to negative 1. Okay? We have 3 steps that we need to do for this. I'm going to write this on the board, and I'm also going to write it on the smartboard as we go through and solve it. Okay? So, step 1. So steps for finding extreme values. So 1, find all critical points. Okay, and I'll go more detailed into the steps when we solve it. I just want to give you guys like the outline here. Okay. 2 is going to be find the corresponding y value for each critical point. And 3, we are going to graph our line using intervals of increase / decrease. Okay? So those are our 3 steps that we need to do. Ready to get into one? A problem. Ready to get into a problem. I have been playing phone tag with AMA. I saved $300 on car insurance.
Oh.
Nice.
Yeah, I was telling Annabelle I feel like a walking car insurance ad now. I'm just really excited about it.
Why have you been playing phone tag with them?
Because they phone me, I phone them, they phone me, I phone them. I leave a message, they leave a message, but I phone during lunches and like before school, and they phone during class time, of course.
Wait, why are you wanting each other so much?
So that you can save money in your turn?
Well, it's just easier to do it on phone.
Wait,
Just-
why do you need to be phoning AMA so much?
Because I'm switching insurance to
Mm.
AMA.
On Tuesday.
Yeah, from a different company.
Oh, I see, I see.
What
Yeah.
company?
It was like Hub International. It's like Wawa Nisa. And now I'm going to AMA.
That's what mine is.
Wawa
Yeah,
Nisa?
same here.
Wawa Nisa?
Well,
No.
what's that?
Oh, AMA.
Oh, AMA.
Yeah,
Mine's
Do you have an AMA
Sure.
card then?
sure do.
I don't know. I have an AMA card, so one of my parents must have an AMA, but my car is one of these things, so I don't know.
Nice. Yeah, you can get AMA cards
Yeah.
just for like,
Roadside assistance, right?
exactly.
Yeah.
Yeah, good.
Except for I've gotten 4 flat tires and my dad has never let me use it.
What?
Yeah, because he's always like, I'll just come fix it myself.
You're like, why do we even have AMA then?
Yeah.
And then like even on the N10 highway, he was just like lying on the side of the highway, just fixing my truck, and I was like, James.
Okay, so let's take into consideration our domain. We only care for values where x is greater than or equal to 1. Okay, so let's just keep that in the back of our mind. And so we're given a function and we care about the slopes of functions. So what do we got to do? Yes, take the derivative.
That's
So f prime of x is equal to 2x minus 3. Okay, so now we need to find all of our critical points. So step 1, find all critical points. Find critical points. So, and here we're going to have 3 parts. So one part we got to find our horizontal tangents, one we need to find our vertical tangents, and then we also need to find our endpoints. Okay? So A, horizontal tangents / stationary points. Okay, so what do we know about this? What does our f prime of x equal when we have a horizontal tangent or a stationary point?
What does f prime of x equal?
Yeah. 0, yeah, good. So f prime of x is equal to 0, so now we just need to solve for when our derivative is equal to 0, okay? So 2x minus 3 is equal to 0, plus 3 divided by 2. X is equal to 3 over 2. Okay, so let's just hang on to that for a little bit. So we know we have a horizontal tangent or a stationary point at x is equal to 3 over 2. Okay? So we'll just hang on to that for now. The second thing we're going to do, B, step B, is finding the vertical tangents. Or undefined values. So what do we know? What is our derivative equal when we have an undefined value?
Isn't that just our points of discontinuity, so it's ones that cross out? Well, I guess not this way.
Not in this case.
Can you say what you said again?
So when does our, okay, so when we have a vertical tangent, what does our derivative equal to? Undefined, right? So now we need to find where our f prime of x equals undefined. What values of x will give us an undefined value? Okay, so 2x minus 3. When does 2x minus 3 equal an undefined value?
Never.
Never, right? Yeah, good. So no undefined points. No undefined points. Good. And C, lastly, C is our endpoints / range. Sorry, domain. Domain, I should say, not range. Domain. Endpoints / domain. And what was one thing that I underlined at the beginning of this lesson?
So it's greater than or equal to
Perfect. X is greater than or equal to -1. Therefore, x equals -1 is a critical point. Right? That's just where our graph starts. That's important. Okay, so that is step 1. That is step 1. Questions? So far, so good? Yeah? Okay, neat. So now step 2, graph our corresponding find our corresponding y value for each of our critical points. So 2. For critical points. And this is, we're substituting this into the original function, right? Are you running out of space, Sam?
Yeah.
Good.
I should have mentioned that it might be that honker. Here's a piece of paper though.
Would tape it in there.
Yeah, you make a little flip book. Okay, find corresponding values for critical points. So we have one critical point, x is equal to 3 over 2, and our other critical point is x equals -1, right? So we'll just put this back into our original function. So we want f of 3 over 2, which is equal to 3 over 2 squared minus 3 times 3 over 2 plus 2. Okay, and put that in your calculator. You'll get negative 0.25 or negative 1 over 4. That's differentiation right there. I know some of you guys like decimals, I know some of you guys like fractions. Okay, so now we know, so when we have x of 3 over 2, we have a y of negative 1 over 4. Whoa, that one got out of control. Don't let your fractions get out of control. Because that's when they'll become irrational or improper.
That's really, really bad.
Thank you.
Always.
Okay, so we know 1, and now let's do our f of -1. So we got -1 squared minus 3 times -1 plus 2, which equals 6. Therefore, another coordinate that we have when x is -1, our y is 6. Okay, that was step 2. Now, step 3. Now, step 3 is graphing. Graph using intervals of increase or decrease. Okay, so we already know some some pretty interesting stuff, right? So x-axis, y-axis. Okay, we have our graph. Sorry?
Then I can fit it. Because this is the last step.
X equals, no it's not, we have another one to go through.
What's that?
Another step?
No, this is our last step. We have another problem to go through.
Yeah.
Oh, okay.
Oh,
Okay, good.
First page.
Okay,
It's a surprise step.
so x is equal to -1. Okay, that's our graph, right? Remember, our graph only exists from, well, the only part that we care about is when x is greater than or equal to -1, right? So we know we have a point at -1 and 6. And we also know we have another point at 3 over 2 and -1 over 4. So like kind of right over here. And again, not to scale. Okay, we're all good. 3 over 2 and -1 over 4 is another one. Okay, so we know a couple points, but we don't really know the shape of it. And I mean, if you went back to grade 11 math, maybe even grade 10 math, you could know that it's a happy parabola, so it has a positive a value, so it must open up. But not all functions are going to be this easy. So let's find intervals of increase or decrease. What do I know? So for increase, what do I know about my derivative when it's increasing? Greater than 0. And when it's decreasing, is less than 0. Okay, so when is 2x minus 3 greater than 0? Plus 3, divided by 2. When x is greater than 3 over 2, it is increasing. Okay, so let's do the other one as well. When is 2x minus 3 less than 0? Well, plus 3 divided by 2. When x is less than 3 over 2, it is decreasing. The slope is decreasing, right? What is this going to look like, Quinn?
I don't even. Well. Oh. There's.
Like a little Nike swoosh, right? Yeah. So we're increasing when x is greater than 3 over 2. Right? And we're decreasing when x is less than 3.2. And that should be a little bit better.
No tangent.
So it's a happy swoosh.
Yeah, a happy swoosh. Okay?
Let's
Okay,
do it.
so just to summarize, what's my relative maximum?
No.
Yeah, -1.6.
This one?
Yeah.
Okay, good. What other points do we have on here?
Turning points.
Okay, yeah.
But like solitary or something. Stationary points.
Yeah. Stationary points, and what's another? Okay, yep. So,
Absolute.
yes, yeah, that's what I'm looking for. So, relative and an absolute minimum. And then, yeah, like you guys mentioned, there's stationary and turning points. Points. 2. Yeah. Good.
That point's got it all.
It's, yeah, it's got it going on. Okay. Perfect. We can get through this next example today, which is great. Because this next one we don't really have to do any graphing. Because it's oh, it actually does say sketch the graph. We're not going to sketch the next graph. Where did, oh, I don't know. Okay, so step 1. What is it?
Find all critical points.
Find all critical points. 1. So critical values. So where f prime of x is equal to what? Equal to paper airplanes? 0, yep. Where f prime of x is equal to 0. And this is for, sorry, I should have been a little bit more clear. That's for stationary points or horizontal tangents. That's when f prime of x is equal to 0. Okay, so y prime is equal to what? Make sure we take the derivative of this, right?
And we have to multiply it by so high.
But it's just 1, right?
Wait, so wouldn't it be 2x minus 2? Wait.
It's times
Wouldn't it just be 3's cancel, so
So-
then it'd be 2?
Yeah, well, I'm just showing all my steps.
Oh, okay.
Yeah, but you're totally right, okay? Yeah, we want to bring down our power, right? And then we're going to subtract 1 here, and then you'll take the derivative of what's inside, but derivative of x is just 1, right? So,
Okay.
not too bad. But yeah, good memory, okay? So 3 times 2 over 3 multiplied by x minus 2, and then 2 over 3 minus 1 is negative 1/3. Yep, sure is. And then multiplied by the derivative of what's inside the brackets, which is just 1, okay? So yeah, so as Quinn mentioned, clean that up, Mr. Jones. And, okay, I will. And then we get 2x minus 2, negative 1/3. That's y prime, right there, okay? So now let's set that equal to 0. So 2x minus 2, negative 1 over 3, is equal to 0. Does anybody remember how we could rewrite this as like a root? Or like as a square root or like a cube root?
Yeah.
Remember when it's 1 over 2, we're taking the square root, right?
So we'll take the cube root.
Nice.
and
Nice.
make the cube root.
Yeah, and then if it's a negative exponent, where does it belong?
Oh, it's 1 over.
On the bottom. Yeah, but so 2 over
Oh, yes.
the cubed root of x minus 2. When does that equal 0? Well,
I would love it.
let's just start by simplifying, right? So we'll multiply both sides by the cube root of x minus 2. That cancels. 0 times anything is
0.
0. So what are we left with? Do we like this? Does that make sense?
2 equals 0.
Yeah.
Confucian.
No likey.
No.
2 does definitely not equal 0.
Weird.
So does that mean that there's no stationary points, or does that mean you have to solve for it?
It means there are no stationary points.
Oh.
Indeed, very good. 2 equals 0. False.
Wrong answer.
2 does not equal 0. So therefore, no stationary points. Because 2 never equals 0. Or we could also say because f prime of x does not equal 0. Ever. Never ever. Okay, so that was A. A was stationary points or horizontal tangents. B will be what? What else have we got to look for?
Vertical.
Vertical? Okay, sure.
Oh, is that not it?
Yeah, no, you're right.
And undefined values.
Yeah, exactly. So undefined values slash vertical tangents. So what is my f prime of x equal here? Undefined, you bet. Okay, so let's find where 2, I don't know how you want to write this. Let's put it back in this form with our denominator. So we have 2 over the cubed root of x minus 2. Where does that equal undefined? Well, what values do we have to really be concerned about? The denominator cannot be 0. Good. Good.
I love your enthusiasm.
You're right though, okay? So when does our cube root of x minus 2, when is that undefined? When does that equal 0? It cannot equal 0, right? So opposite of cubing, the cube rooting of something is what?
Cubing.
Yeah, and what is 0 cubed?
0.
I genuinely put 0 cubed in my calculator last night because I wanted to make sure it was 0.
Yeah.
So you know how
There's
sometimes...
goofy ones where like you put it to the 0 and it's like 1.
Yes, that's the
Yeah.
one, right? Yeah. Yeah, when it goes to the exponent 0, then
Yeah.
it's 1.
Which is weird.
No, when it's to the exponent...
Yeah,
Yeah, when it's
that's
exponent to the 0. Right, right. And now when it's the exponent 3. Okay, for sure. So then x minus 2 is equal to 0. So add 2 to both sides. Let's go, let's get some more page. Let's go. Okay, then we get x. So x cannot equal 2, right? That's what we got. and that is a critical point. And C. C is what? What's the last thing we gotta check out for? The domain? Is that what you said?
It's on the other side.
Nice. Domain slash endpoints. Do we have any limitations other than our one undefined value for our domain or endpoints? Do we have any restrictions for a cubic function? What do you say?
No.
No. Okay. Main XER. Cubic are defined everywhere. Neat. Okay, so that was step 1A, 1B, and 1C. What was the second step?
Find the y values.
Yes, find our corresponding y values.
Did it go? Thanks. I feel like this class is really quiet today.
I'm intaking everything.
We miss Emma.
Yeah.
Yeah.
I just saw my life flash before my eyes.
I missed.
So our critical points, we had f of 2, and this goes into our original function, right? So 3, 2 minus 2 to the 2/3 plus 1.
Don't.
So when f of 2 is equal to 1, therefore we have a point at 2 and 1. Okay, so what are the extreme values on here? What do we know? Well, I'm gonna tell you.
Are the extreme values all of the ones we're listing?
This, yeah, so for 1A, we didn't find any extreme values, right? For stationary points. For 1B, for undefined values, we found that x cannot equal number 2, right?
Right.
Cannot equal number
And
2.
that
X
makes
cannot equal 2.
And so what classifies something as extreme?
Those dots that we had at or these topics that we had at the beginning.
Those are all extreme?
These are all extreme
Oh.
values, yeah. So anytime there's like a curve or a flat spot or like a V, those are all
All extreme? Okay.
all extreme, yep.
It feels like the max and min should be extreme because they're the most extreme part of the graph.
Say that again, sorry?
Well, like, I feel like the max and min should just be the extreme because like they're the most extreme part of the graph.
Yeah, I
Like,
feel
they're
like
either really happy or they're really sad.
Okay, so I'm just gonna write this down. So 2, 1 is a relative max min. Relative min and absolute min, sorry. Relative min and absolute min.
How do you not?
How do we know this? Good question. Good question. So, well, you should sketch the graph.
Question.
If we sketched the graph on this one, I had to cut it short for a little minute. You could also put it into your calculator to check your answer. Okay?
Sam instantly.
There's a relative min and absolute min.
Except for, I thought that x
I'm good at
can't
that.
equal 2.
Put it in the graphic calculator.
X cannot equal 2.
Yes, you're right.
You are right. So, why? Oh, this just means,
We're finding
sorry.
the undefined point.
That just tells us that we have an extreme value at that location.
Oh, that's good to know.
Yeah, yeah.
So it's
Uh,
not undefined.
it's just that so the slope is undefined. Remember we had that pointy ice cream cone one?
Okay.
Yeah, that's what that means there.
So the slope is undefined, the graph is undefined.
Yeah, exactly. So at 2, 1, we have an undefined slope. Yeah, really good point, Karen. Okay? And this is also a cusp. And if you guys are like, what's a cusp?
Pretty cool.
Flip to the back page and read your cusp. Okay, so a cusp is a point where two tangents merge into a single tangent. Tangent to the left of 2, 1, and a tangent to the curve of right of 2, 1 would become closer to vertical as they move near 2, 1. And at 2, 1, those tangents coincide, and it's undefined.
Are there any other points, or is the only extreme points the relative to the absolute?
This is the only extreme point on this particular question.
Oh, that's nice.
I knew that from graphing it.
Okay, Sam.
Yes.